Hello, everyone, and welcome to today's Solutions webinar. My name is Andrea Hall, and I am the Customer Relationship Manager here at Saratech. Today, we have a special guest. We have John Bannon, who is a Senior Commercial Applications Engineer from Markforged. He'll be talking to you about identifying opportunities for 3D printing and manufacturing. Just a quick overview of what we'll be doing today. The agenda, we'll just do a quick introduction. And then John will be talking about, like I said, finding additive manufacturing applications, and then we'll have some time for questions and answers at the end. If you do have questions during the webinar, please feel free to type them into the chat box or the questions box over on the right-hand side of your screen. Just a little bit about Saratech. Saratech at its core is an engineering company. We help customers solve engineering and business challenges by providing software, expertise, and manufacturing solutions to optimize product development. Since 2002, we've been helping customers optimize their design analysis and manufacturing processes. Saratech is an award-winning solutions provider in the PLM space. We earn the trust of our customers by delivering results and building resilient relationships. Headquartered in Orange County, California, our team of professionals are located all over the U.S. to best support our customers. And like I said, if you have any questions or comments during the session, you can type them in that chat box or in the questions box on the right-hand panel. And with that, I am going to pass the baton over to John.
Great. Thanks again, Andrea, for the great introduction. Hey, everyone, and welcome to today's presentation. Again, my name is John Bannon, and I'm a Senior Applications Engineer at Markforged. And today we're going to be talking about manufacturing and 3D printing, something we're calling walking the line, Markforged on your plant floor. So with that, let's go ahead and jump right in and get started. So we're really going to focus today on how to identify some well-qualified applications for high-strength 3D printing in your own manufacturing operations. And these are the same strategies that my team of engineers uses every day to help our customers solve a lot of engineering challenges in their processes. And we're really going to start and end with three key takeaways that I want you to bring back with you as you look at your own operations and facilities on how you could use the strategies that I'm going to talk about today within your own organizations. Then we're going to briefly discuss why Markforged has such a strong focus on manufacturing. And then we're going to get into the real meat of the presentation today. I'm going to walk you through three strategies or lenses through which my team views a manufacturing operation as we walk through a factory floor. And then after that, we'll address any questions and we'll make this as interactive as possible. If you do have questions during the presentation, please feel free to use the chat box for the questions. We'll pause the presentation in order to address those. We'll also address questions at the end. So I really want you to keep an open mind and challenge maybe your conventional wisdom about where you can use 3D printed parts in your processes. Because traditionally, 3D printing in general has really focused on prototypes and on the product development side of things for a really long time. But Markforged is much better suited to industrial manufacturing and tooling applications, and that we'll talk about during this presentation. So I really want you to challenge your attitudes, existing attitudes and assumptions here. And as part of that, I'll be doing, and I bet there's a lot of people listening that are really pretty hands-on technical people, myself included, and I think the best way to demonstrate to yourself the value of industrial strength 3D printing is to have a printed part or parts in front of you. And to that end, we're going to give you a lot of examples today of successful manufacturing applications of our tech to help you choose some good potential benchmarks parts that Saratech can help you prove out. And finally, it doesn't really make sense to bring in a machine in-house without knowing the kind of value that you're going to get out of it. So I'm going to point out some other cost savings to consider when thinking about the type of return on investment you could see with Markforged. So who should I ask for help? And this question, before we really dive into this, one of the best resources you have is your people. Every one of your teams will have some particularly good experience when you're looking for 3D printing applications. From your tooling and process engineers, know the kind of tooling and fixtures you're using, as well as the inefficiencies in your current processes. while your line supervisors and operators likely know which issues arise on your line as well as where things are going to go wrong. On the maintenance side, your maintenance engineers have a ton of experience repairing those existing machines which often break, as well as which critical repair parts are difficult to acquire. And then finally, your quality team knows where your product quality is being impacted by your existing tooling. And the inspection or the QC room is always a really favorite spot of mine when I'm touring a plant because there's always some solid potential 3D printing applications there. So this brings us to the bulk of our presentation today, which is to share with you 3 strategies that our team uses to identify great opportunities for 3D printing and manufacturing. And these lenses, using air quotes, so to speak, that we look through our discussions of the pain points and the cost drivers, common manufacturing applications, and materials used in tooling and fixtures that we frequently can replace. There's definitely a bit of overlap between these 3 categories, so don't think of them too rigidly, but they're a great starting point to view your operations from multiple perspectives. So my team often finds that if we approach application discussions from these varying angles, then we're much more likely to run into opportunities for significant process improvement. So let's just jump right in and start talking about a couple of these. So first, we're going to talk about the cost drivers, your inefficiencies and areas of your manufacturing operations that really keep you up at night. As an applications engineer, one of the reasons that I really enjoy working with manufacturing is that compared with a lot of other sectors, the input costs are highly measured and known. And that really helps us qualify the opportunity you have to reduce costs with 3D printing. So Markforged parts, they can often reduce high manufacturing costs stemming from waste, downtime, and inefficiency, which is why many of our customers see such a fast return on investment. So the first thing that you should do when you're evaluating an application in your facility is to ask yourself what your all-in costs are for that particular component. And this will help you judge whether or not you will be able to significantly impact your operation. So when it comes to actually reducing these costs, some of the biggest opportunities we see are reducing unplanned downtime, making it more efficient to change over a manufacturing line from one product to another, as well as reducing the cost and the effort of upgrading your existing machines with new sensors and safety equipment. And finally, we're going to talk about something I like to call cardboard engineering or duct tape engineering. And it's not a particularly technical term, but I think you'll recognize what I'm talking about when we get to it. So one of the biggest cost reduction opportunities is to reduce unplanned downtime. And really, let's just talk about quickly what that is. It's something known by a few different terms. Basically, we're talking about production stoppages that you didn't plan on having, whether due to equipment failure or some kind of jam in your line. It can come from a number of different sources, but the bottom line here is that any unplanned downtime is lost productivity, and that equals a lot of money built up. So if printed parts can mitigate some unplanned downtime, there's a huge, significant cost savings to be had. And that's exactly what one of our customers did. There's an automotive manufacturer that produces a car every 12 seconds. So you can imagine when a line goes down, that cost builds up pretty significantly and rapidly. And in this case, their car frames were positioned in their assembly line using a set of aluminum guide pins. As the cars were loaded on the line, they tended to impact those pins, and that cyclic loading would eventually cause the pins to break. So when one did, the car bodies in that cell would misalign, jam, and bring down the whole line. So one of their engineers decided to print replacement pins with nylon and carbon fiber, and all of a sudden that line and cell stopped seeing failures. And after a couple of months, that improvement demonstrated such a significant cost reduction that the engineer and the boss replaced all the pins across their entire product line, which resulted in a massive decrease in lost production due to downtime. So when you're looking for these opportunities, you want to look for areas where 3D printed parts can either prevent unplanned downtime, or like our automotive customer here, they can mitigate the impacts of it by quickly bringing the manufacturing line back up through printed replacement parts. So another area to look at is your changeover process when reconfiguring a manufacturing line from producing one product to another. The process of recalibrating your equipment can often take days and of labor and lost productivity. So if you have a lot of manual calibration steps without extensive documentation, such as adjusting things like guides, nozzles, or chutes, a simple 3D printed changeover jig can often bring you back up and running much faster, offering significant cost savings to that process. So this is an example of a quick changeover calibration feature. All of the black parts in this picture represent 3D printed parts. So this bar holds a series of rails which direct a range of work in process parts into a robotic cell. And the assembly rails can quickly be adjusted to match the size of the product line being assembled. There's often a lot of opportunity to print components which upgrade or repair aging machinery. So these could be brackets and mounts for sensors which monitor your processes. These could improve both the yield and efficiency. They can also be parts to mount modern safety equipment and keep older machines compliant with modern regulations. So in this picture, we have a common example that I see where mounts and pass-throughs for e-support pull stop cords, like the one that you see here, are printed to ensure there's access to an emergency stop around the entire machine. Here we also have a 3D printed part to hold the calibration center in place for a robotic cell. And finally, a really common phenomenon we see in manufacturing plants is something I like to call cardboard or duct tape engineering. And these generally are some sort of temporary fix that wasn't documented, but was put in place to hit an upcoming production deadline, and that never got replaced with a permanent solution. Most likely, you look at this picture and you're like, oh yeah, I know exactly where I have something like that on my manufacturing floor. So a 3D printed part would work really great as a replacement for that duct tape solution. So the easiest way to spot one of these is to ask yourself, is it held together with tape, putty, or hope? And what it looks like is something like this. This is an actual example where a machine to the left of this picture was a ½ inch shorter than the machine to the right. So what we're looking at here is compressed air tubing to blow parts from one machine on the left up a ½ inch so that they can easily transfer to the machine on the right. And this, of course, isn't documented. So every time the product moves through the system and the system needs to change, there's a lot of time spent readjusting that tubing to ensure that it's pointing in the right place and that those components are being passed correctly to the next machine. So instead, a set of 3D printed calibration jigs or fixtures would ensure a much smoother transition for this particular issue. Okay, so these are simply some good questions to ask yourself to help identify some of the cost reduction opportunities we've discussed in your operations. So things like what area or specific process is costing you the most? What's your biggest cost of loss, waste, scrap, or unnecessary manufacturing costs? What breaks or is replaced often, and how much does it cost when it does? And what are your sources of unplanned downtime? What parts do you absolutely need to stay running 24/7, 365? Do you have any areas where things are fixed with duct tape, cardboard, zip ties, hope? And do those cause issues when updating your lines? So in the people in your plant or your manufacturing facility that are going to be the relevant experts here, this ranges from management in your manufacturing, production, and maintenance teams who have a good handle on costs, to your machine operators who should know where the processes are going to go wrong and where there's some cardboard engineering that could be fixed. So we're going to move on to our next section, and now we're going to talk a little bit about common manufacturing applications for 3D printing that can be seen across a wide range of industries. So these generally fall into one of three categories: machine setup, fixture positioning and tooling, and line optimization. So machine setup includes things like calibration jigs, repair parts, and maintenance tools. And on the fixturing and tooling side, we're looking at things like soft jaws and workholding, assembly and inspection fixtures, and any other alignment devices. And on the line optimization side, These are the 3D printed brackets for upgrades and improvements that we discussed in the last section on cost. So some of the most common uses for Markforged parts are in a lot of tooling and work holding, which is why I usually insist on taking a detour to the manufacturing floor when I'm visiting a facility. And what I'm looking for in those shops are really soft jaws and other fixturing for both lathes and mills. Soft jaws, like the one pictured here that's highlighted in black, one of these. They're really a production inefficiency because although they're relatively quick to produce, although more complex ones can take a long time, but the bigger issue is that while they're being cut, you aren't using your machine to produce components which are directly used in your manufacturing. So if you print soft jaws, you can ensure that the tools like your CNC mills and lathes are producing more valuable output. So here's an example of a more complex 3D printed soft jaw to hold a sprocket in a vise inside of a CNC mill. So engraved jaw 1 and jaw 2 were both printed on Markforged 3D printers to hold the sprocket in place for CNC operations. One additional aspect of 3D printing work holding with Markforged is that it's non-marring, which means your work holding is less likely to cause surface damage to your products. This also reduces the rework and polishing required and can directly improve your product quality. So most manufacturing companies have shelves or drawers full of fixtures and work holding components, which represent parts that can be 3D printed. So 3D printing a set of soft jaws with onyx and carbon fiber is a print that can take less than a day versus the traditional 6 to 8 week lead time for manufacturing the same parts out of aluminum. So the next example is work holding for the casting seen here that's held in place while the flash is ground off. So this is an old fixture made out of aluminum, and it worked for some of the castings, but for large portion had extra flash which interfered with the fixture wall and either braided the walls or wouldn't fit. So the long lead time for the fixture meant that better iterations couldn't be easily turned around. But in contrast, the two fixtures that we see here, these were quickly and easily turned around and integrated with steel hex stock as wear-resistant inserts. The fixture was much cheaper, it fit better, the castings coming out of the foundry, and it was much more wear-resistant due to the steel inserts. And it's easily replaceable if it does break or you need a new one. It's much easier to 3D print that than it is to wait for the tooling to come in. Machining fixtures. So let me just go ahead and play this video. In other cases, you may need a fixture to hold a part down to your CNC table while machining. So 3D printing can come in handy here as well. This particular part is a mount for a motorcycle that requires 2 machining operations. Since the second one was on the flip side, a fixture was 3D printed to hold the part down to a table with high precision. So the part being held is in the upper left, and we have a video showing the part being machined on the fixture in the upper right. Markforged onyx material is very chemically resistant to the cutting fluids used in CNC equipment. And then the part in the lower left is the finished part, and the part that's on the motorcycle frame is in the lower right. Oops. So we also see quite a bit of tooling mounted to the end of industrial robots. So that we're all on the same page when we're talking about end of arm tooling, we're referring to the manipulator and the structure at the end of the robot's arm past the arm's wrist. And in this case, we replace these 3 gripper jaws with 3D printed parts. So this is an example from one of our customers, Dixon Valve. of some of the end of arm tooling to move casted pipe coupling blanks between two machining centers. These three printed jaws brought the cost of tooling for this specific coupling down from $1,000 to $27, so $9 per print. This is one of the handouts that's available for download through this webinar. Under handouts, there's 4 handouts that I'm going to be referencing that give case studies and white papers about the customers that I'm talking about in this presentation today. Here's another example from one of our customers in the packaging industry. This is a vacuum manifold at the end of a pick and place robot, and the suction cups hold unfolded cardboard boxes while the robot arm moves the box. In a better view, kind of the underside view, showing the suction cups, a cool aspect of this tool is that the customer actually printed internal vacuum channels into the part to eliminate a lot of the tubing, which significantly reduced the manufacturing complexity and the cost of this part. So let's take a look at a common and fairly common scene in manufacturing that I want you to see how many areas that you might be able to use high strength 3D printed parts in. So I'll give you guys a minute. This really isn't interactive so much as it is just to kind of make mental notes about where you see 3D printed parts. But there's these are a couple of assembly robots from an automotive manufacturing line. And even outside of automotive, I've seen similar setup across a wide range of industries. So where and how many applications do you see that could be replaced with high strength 3D printed parts? So first, there's a number of grippers and end of arm tools. We also have some brackets for routing various cables. I see what looks like some cradles or nests for holding parts in place, as well as a number of different hold downs and clamps to retain the pieces of the vehicle frame. I think I'm counting about 10 applications at a fairly quick glance, but there's probably a lot more than that. So another area I always make a point to visit is the inspection of the QC room, where I usually find a lot of fixturing opportunities. So our team likes to visit the inspection room because quality is super important in all manufacturing, and every QC room has a need for fixtures at some point. So in this example, this is from a customer of ours, JJ Churchill, who is using a CMM to measure the profile of a turbine blade. And we often see with parts being fixtured on CMM that they're using putty or modular fixtures, but these all have downsides. 3D printed fixtures are a great solution because they're cheap, they're repeatable, and easy to produce, and they don't require anyone in the inspection area to have any machining experience or access to CNC equipment. So the bracket, the black bracket here that's holding the blade is onyx reinforced with carbon fiber, which created a part that prevents any deflection or movement of the blade as the CMM probe touches the blade. Another example that we talked a little bit about with immediate impact are soft jaws for your CNC lathes or mills. And these pieces of CNC equipment, work holding, are often required for subtractive manufacturing operations on complex parts. And soft jaws can take just as long or longer to produce as the parts themselves that they're holding in place, and can sometimes double the overall manufacturing time and cost of the part. So by 3D printing these parts, you can offload a huge amount of work from your operators in your CNC machinery to an unmanned 3D printer. So in this case, jaw 1 and jaw 2 aren't holding a sprocket, but are holding a much more complex component in place that, again, doesn't mar and is highly rigid in order to allow your CNC equipment, mills, and lathes to machine that component. Another great example is custom welding fixtures for 3D printing, especially with complex angles or difficult positioning prior to welding. So here's an assembly being welded on that fixture. So onyx is conformal and has a heat deflection temperature of 145 C, which is 293 degrees Fahrenheit. If you reinforce onyx with high strength, high temperature fiberglass, then you get a part with a slightly higher heat deflection temperature at 302, 303 degrees Fahrenheit. And because you're reinforcing with fiber, that fiber has a similar strength to aluminum. And high strength 3D printing also enables us to start printing functional custom tooling as well. And I'm always on the lookout for custom tooling in a shop. So in this particular image, this is a custom 3D printed bar puller for a CNC lathe. This is what I'm talking about right here, this part. It's mounted on a turret on one of the lathe's tool holders. So bar pullers are used to advance raw feedstock in lathes without integrated bar feeders. They allow a lathe to advance bar stock after finishing a part and automatically start on producing the next part without operator input. So a CNC lathes with bar feeders tend to be more expensive. So a $13 3D printed part like this allows smaller machine shops to produce volume parts on much lower cost equipment. This is another good example of those bar pullers. Because the bar puller was printed, you can pretty much get any geometry that you need. And so in the case of this particular machine shop, they were able to print a number of different geometries to handle the bar stock that they needed to work with on demand, which offers significant flexibility, as well as cost, because that $13 bar puller replaces a $700 to $1,000 standard CNC bar puller. And why would you replace one with the others? Because it's much more customizable and replaceable in case of breakage. And one last application that we see a lot in manufacturing is with 5S tool strategies, 5S organizers. So you might be pretty familiar with 5S, but if you're not, it's an organization methodology that originated in Japan and is commonly known for adoption by Toyota in their production systems. 5S itself is a method for ensuring very organized, efficient operations, but also has a physical manifestation in some organization equipment. Kind of give you an example of that, where and why you should use 5S, or why use or implement 5S at all, to avoid scenarios like this, where their tools spread all over the shop. It's not convenient to find anything. Compare this image with something like this drawer, which has 5S driven foam liners organizing tools. And it doesn't matter who goes to that particular drawer, easily find the equipment and the tools that you need to do your job right away. And here's another drawer with nicely arranged micrometers. The downside to these types of organizers, however, is that they're not easy to change. 5S organizers are often purchased as part of a larger institutional push towards organization. And when tooling needs later change, there often isn't budget to update those organizers. Additionally, few shops actually have the hot wire foam cutters to cut the new inserts themselves. So a more flexible option is to 3D print modular pieces for specific tools, which allows you to future-proof against new tooling needs. Okay, so there are a few more questions that you should be asking yourself as you're walking through your facility. Things like, where do you use the most fixturing and work holding? Do you have an inspection QA, QC room, and how do you fix your parts currently? Do you do assembly in-house? Do you build your own fixtures? And how much does out-of-house fixturing cost you? And the resident experts that you have at your disposal to help answer these are going to be more on your engineering side, on your production, manufacturing, and maintenance teams, as well as your inspection room with your quality manager, engineers, and technicians. And our final strategy for identifying opportunities on your manufacturing floor lies in materials, specifically those which are commonly found in tooling and fixtures. So we generally see that Markforged can replace traditional parts made from some common engineering metals and plastics. So on the metal side, this includes aluminums, tool steels, stainless steels, and carbide. And on the plastic side, this includes common engineering plastics like UHMW, which is an ultra-high molecular weight polyethylene, as well as Delrin, which is a trade name for acetyl resin, nylons, and Teflon. You'll notice that some of these materials have an asterisk next to them. And this is because parts made using these metals and Teflon often only need certain contact surfaces with these material-specific properties. Oftentimes, you can 3D print a replacement part which utilizes an off-the-shelf insert, what we call a COT, or component off the shelf, from these materials for a much cheaper and lower effort solution, which can have a significant impact across your manufacturing facility. So let's take a look at a typical factory example. This is a motor manufacturing facility, and the blue block at the bottom here is a conformal cradle or pad to hold the motor in place while it's worked on. Fixtures and cradles like this are very typical in an industry or in an industrial manufacturing environment, and we often find that they're made from nylon, UHMW, and Delrin because these applications are used for non-marring and impact-resistant properties. Markforged parts can easily stand up to these same environments, and there's no penalty for fixture complexity. Unlike machining, 3D printed time doesn't really depend on the complexity, just on the volume of the part. So the more complex a feature, the more attractive it can be to 3D print versus CNC machining. And this is an example of another cradle made of UHMW from a customer that manufactures heavy industrial vehicular frames. And these vehicles are dropped into the cradle and as they're moved between various manufacturing processes. So even a simple geometry like this can have a long lead time from internal or external machine shops. By printing this part with Markforged onyx and Kevlar materials, you get the same impact resistance, and you can see significant decreases in cost and lead time with very similar performance. And on the metal side, another example from one of our customers, Aero Global, who manufactures window solutions for mass transit applications. They replaced aluminums and steel fixtures and drill jigs for some of their production equipment with a nylon and fiberglass version that was 3D printed with Markforged, which was a much tougher and more abrasion-resistant solution. It was also significantly faster and cheaper to iterate on the 3D printed parts and arrive at a final production solution than it was to wait for that same part to come in from the long lead time with metal. So finally, here are some additional questions to ask yourself specifically related to the materials you use in your facility, including things like, do you use nylon, Delrin acetyl, or UHMW in your plant and where? Are you using aluminum, tool steel, stainless steel anywhere? Do they need to be those materials, or are they just readily available and on hand? And how long does it take to turn around those parts with the above materials in-house? And what kind of effect would it have if you could replace those same components with a 1 to 2 day turnaround on similar parts? And the experts that you should be asking or getting their input on are, once again, in your engineering departments, from production, manufacturing, and maintenance engineering. So I hope this presentation helped you keep an open mind and challenge conventional wisdom about where you can use 3D printed parts in your processes. Also to discover new applications through the search strategies that we talked about, and also identify inputs to help you build your return on investment to model and estimate the opportunity you have within your manufacturing facility. Thanks for listening, and let me know if you have any questions.
Thank you so much. Great job, John. It doesn't look like we have any questions at this time. We'll give you another minute or so here. Some of you joined late, so just a quick reminder, there are some handouts that Markforged provided for us that were mentioned in this webinar, and they are in the handouts section of your panel, your GoToWebinar panel on the right-hand side. So if you'd like to download those, go ahead and do that now. We can also send them in the replay email that we'll be sending out to you. We can attach them to that email as well. And just a quick reminder, if you're not already, please follow us on all of our social media outlets. Most importantly, our YouTube channel, the Saratech YouTube channel, is very informative. We have lots of different videos on there, shorter videos, longer videos. And if you ever have any suggestions or anything that you'd like to see in these webinars, we are very open to suggestions as well. But let me just check our questions in our chat box here one more time and see if we got any questions. It looks like we're all set. John, you must have covered everything.
All right, fantastic. Well, thank you everybody again for your time.
Yeah.
And if you do have any questions, please reach out to Saratech.
Yep, absolutely. And we'll be happy to loop John in if there's any questions that he can answer. And then if you don't mind, just stick around for about 30 seconds after the webinar and just fill out a quick little survey. Let us know how we did today. And if there are anything that we can improve upon, we are always open to that as well. And if you have suggestions for future sessions, we're open to that. And thank you all. Have a wonderful day.